Imagine this. You wake up one morning, have your breakfast, and look at the sun through your window. Everything seems normal, right? But let me tell you a secret. Our sun is actually slowly dying. No, this won't happen tomorrow. Don't worry, you can keep paying your rent. But in 1 billion years, things are going to get a bit tricky. Hello, I'm Seho, and welcome to the Mystery Lab channel. Today, we're embarking on a cosmic detective story. We'll explore the aging process of our sun, the evaporation of Earth's oceans, and scenarios where humanity might migrate to Mars or even further to survive, all with a science fiction twist. Enjoy the show. Our sun is actually a middle-aged star. Think of it like Tom Holland before he turns into Spider-Man.
It's 4.6 billion years old, and in a stable phase we call the main sequence. But here's the secret. Every second, 600 million tons of hydrogen converts to helium in its core. This is a massive thermonuclear reactor, and this reactor, unfortunately, won't run forever. Now, this is where things get interesting. As the sun ages, it actually becomes brighter. Imagine this, like someone approaching retirement trying to show everyone one last time what they've got. According to scientists' calculations, the sun becomes approximately 10% brighter every 1 billion years. Well, what's 10%, you might say? But on a cosmic scale, 10% means the difference between ashes and paradise for Earth. Exactly 1 billion years from now, yes, this is a very long time, 15 times longer than the extinction of the dinosaurs, the sun's brightness will reach a level that makes Earth uninhabitable. The balance of greenhouse gases in the atmosphere will break down and an irreversible process will begin. Think of the gravitational lensing effect. Just as light bends when passing near a massive object, the sun's increasing radiation will completely bend, distort, and destroy Earth's climate system. Now the real cosmic detective work begins. As the sun emits more energy, a process called runaway greenhouse effect will start on Earth. Think of it like a figure skater. When the skater extends their arms, they spin slowly, but when they pull them in, they speed up. Earth's greenhouse effect will also accelerate uncontrollably. Evaporation from the oceans will increase. Water vapor is already a powerful greenhouse gas, even more effective than carbon dioxide. And here's the vicious cycle. More evaporation, more greenhouse effect, higher temperatures, even more evaporation. Within the first 200 to 300 million years, which is still a very long time, don't worry, the upper layers of the oceans will slowly begin to evaporate. The pressure on Earth's surface will increase. Temperatures will exceed 100 degrees Celsius. Do you remember the Doppler effect? When an ambulance approaches you, the siren sounds high-pitched. When it moves away, it sounds low. Similarly, as water molecules escape from Earth into space, life on our planet will also end with a high-pitched scream. In approximately 1 billion years, most of our oceans will have evaporated. The remaining water will be frozen in deep craters and at the poles. Earth will transform into a hell similar to present-day Venus. In this process, first marine life, then terrestrial plants, and finally even microorganisms won't be able to survive. The irony is this: life on Earth began in the oceans, and it will end with the loss of the oceans. A cosmic full circle. Now we get to the fun part, survival plans. The first and most logical option, Mars. The red planet is currently cold and barren, but as Earth heats up, Mars might actually become more temperate. Imagine this. As the sun brightens, the frozen carbon dioxide and water ice on Mars will begin to melt. Perhaps a natural terraforming process will begin. It's as if the universe is telling us, my child, one door is closing, but another is opening. But of course, there's a problem here. Will humanity still exist in 1 billion years? Dinosaurs lasted 165 million years. We're still 300,000-year-old babies. So either our super-evolved versions will go to Mars, or we need to find another solution.
Moons like Europa, Enceladus, and especially Titan are also interesting options. Titan already has a dense atmosphere. It's the only place outside Earth with liquid on its surface. Right now, there are methane lakes at -180 degrees, but when the sun brightens, who knows? Maybe it'll become a warm vacation spot. Of course, there's a paradox here, like dark energy. How will we get to such distant places? Spaceships? Generation ships? Or cryogenic sleep like in science fiction movies? The most interesting option, building giant space colonies. Imagine massive rotating structures called O'Neill cylinders, cosmic apartment buildings creating artificial gravity. Here, the dark energy concept offers an interesting analogy. Just as dark energy expands the universe, humanity can also expand its living space throughout the solar system. Using asteroid resources powered by fusion energy, mini worlds with their own ecosystems. The most extreme option, migration to nearby star systems like Proxima Centauri. It's 4.24 light-years away. With our current technology, it would take about 80,000 years. But who knows what technologies we'll have in 1 billion years? Maybe we'll build ships that reach 10% of light speed and embark on 50-year journeys. Or, science fiction fans pay attention here, warp drive or wormholes will become real. Here's the beautiful part. 1 billion years is really a very long time. To gain perspective, think about this. The first multicellular organisms appeared about 600 million years ago, so we have twice that amount of time ahead of us. In that time, humanity will probably become unrecognizable. Maybe we'll upload our consciousness to computers. Maybe we'll become an entirely new life form. Who knows? Maybe we won't even prefer to watch the sun's death because we'll have colonies in other galaxies. The cosmic lesson to take from this story, the universe is constantly changing. Stars are born and die, planets form and disappear. We're part of this great cosmic dance. Our sun has gifted us approximately 5 billion more years of life, including the challenges 1 billion years from now. Yes, friends, today we tackled a somewhat depressing topic, but I hope we stimulated your scientific curiosity. Remember, gravitational lensing shows us distant galaxies. The Doppler effect proves the universe is expanding, and dark energy pushes everything apart. But science always brings us closer to solutions. If you enjoyed this video, don't forget to hit the like button, subscribe to the channel, and tell me in the comments, where do you think humanity will be 1 billion years from now? On Mars, on Titan, or in a completely different galaxy? See you in the next video. I wish you clear skies. Goodbye.